Hi, I'm Ricky Castles, an assistant professor in the Department of Engineering at East Carolina University. In 2013, I created a brand new microprocessors course as part of our electrical engineering curriculum. I wanted to ensure that this new course included plenty of hands-on learning to give the students opportunity to practice the theory that they were learning in the classroom. 2 years later, I realized that the students didn't have enough opportunity to practice what they were learning in the classroom in the lab time that was allotted. So I flipped the classroom and allowed the students to watch my video lectures online before they came to class. So now, in each of their lecture periods, they can have plenty of opportunities to practice. This class includes the opportunity for students to learn how to control various types of displays, to control actuators, to learn how to collect data from sensors, and to perform serial data communication. In this video, I want to introduce you to the platform that we use and some of the lab assignments I have my students do throughout the semester. This is the QL200 trainer board from pick16.com. As you can see, the trainer board comes enclosed in a case that the students can carry, like a small briefcase. This helps to protect the components that are inside of the board and allows the students to have a small package that they can carry with them on the bus, in their backpack, back and forth from the classroom to the lab and home. If you look inside, there are several components on this trainer board. The main component here is a microchip PIC16F887 microcontroller. This is a 40-pin dual inline package microcontroller, and it can actually be interchanged, and various other PICs can be used to program this device. This trainer kit includes 6 7-segment displays that the students will learn to program. It includes push buttons that are interfaced with several of the ports on the PIC. It includes this arrangement of push buttons which acts as a 4x4 keypad, and it includes a 2-line LCD. The students have a reset button that they can use to reset their code, and then over here they have various pin headers that they can actually connect wires to so that they can put other circuits over here to program. The students go through various labs. In some labs they learn to turn on and off LED switches here just by exercising some of the ports. They learn to pull in information about which key is being pressed by going through various routines. They learn to put messages out on the display. They learn to put information out onto a 7-segment display. They learn to interact with the various push buttons. There's also a piezo speaker on here, so they learn how to make sound and digital music. This port allows them to connect a stepper motor so that they can control the position of a stepper motor over time. I have now attached the included USB cable and loaded up the program that our students are tasked to develop partway through the semester. This program will act as a digital stopwatch, and the students are tasked with programming it so that the stopwatch starts running and stops running when this button is pressed. They also have to display the current time in hundredths of seconds, tenths of seconds, seconds, tens of seconds, and minutes and tens of minutes. So the students have to learn a variety of things. They have to learn how to program an interrupt so that when this button is pushed, it automatically stops and holds the time. So after 3 seconds, it has stopped the timer, and then they resume. They also have to learn how to turn on these various 7-segment displays, and so there's 2 ports that do that. One of the ports determines which of the segments are on, and then the other port is actually cycling very quickly through each of these 6 displays so that they can see the various numbers on there while only turning on one display at a time and relying on persistence of vision to keep the other displays in your mind. They also learn a good bit about microcontroller timing, so figuring out exactly when to increment that so that it only happens every 1/100th of a second is an important task. The students have a homework where they write assembly code to develop a 1/100th of a second delay routine, and they have to figure out the timing in assembly. Then they also have to develop interrupt code. They have to develop code that puts each of the numbers out on the display, and this is built up over several in-class assignments. At first, they learn to read from a push button. They learn about the importance of debouncing push button circuits. They also learn about how to put various values onto displays, and they do that with a static display at first, where they just put out a constant number and hold it there. I give them an assignment where they have to put their birth date out in month date, and year on the display. And then they get to this. And they can see timing in a variety of ways. In this class, I teach them both in assembly and in C, and so the students can use assembly to develop the exact right timing. And then they can also go back and in C, they can put in a timing macro. They can also learn about how to use the included timers that are part of the PIC microcontroller so that they can set a timer to overflow at the exact right amount of time. In another lab, the students learn to use this 4x4 keypad as an entry pad for a cell phone and to display the results on this LCD display. The numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are mapped to the first 10 buttons, and then the remaining buttons are to be ignored. So as students push these other buttons, nothing happens, but then as they push numbers that are valid entries, you can see on the LCD display that they can enter 3 digits, and then once they receive the fourth, the first 3 digits are encased in parentheses, and then after they receive another 3 digits, upon receiving the 7th, the dash is input, and then once all 10 digits in the phone number are received, the LCD display goes to the second line and displays the word dialing.